They are. Okay. Now I'm going to put my Rails project here in this folder where I have a whole bunch of Rails projects. And so what I'm going to build is a, say, Rails new. I have to make sure that Rails is finished installing over here. Oh, it's still installing documentation. That's fine. Okay, so I need to pick a name, and I'm going to make just like a simple to-do list application here. So I'll call it like to-do list. And this is the part of the process where Rails just sets up the file and folder structure for you, and it gets you ready to be working with sort of a default Rails application. And so I will now have a folder in here called to-do list. Here it is right here. And I'm going to open a second command prompt into there. I tend to have 2 or more command prompt windows opening or opened when I'm working on a Rails application, primarily because one of them is almost always running the Rails server. And so I don't want to have to continually close the Rails server in order to do things like run the Rails generators. So I'll have like one command prompt running generators, the other one continually running the Rails server. So I've got those 2 running. I'll finish, let this one actually finish. What it's doing is it's running bundle install. So Rails is a set of gems. And so when Rails first creates itself as a project, what does it say? Bundle show to see. Okay, that's good. It puts into the project folder a gem file, which describes all the different gems that Rails depends on, and then it runs bundle install, which looks at this gem file and just ensures that your system has all the gems that are required to run Rails. And so gems are just sort of a generic Ruby thing, and so as a Ruby project, there's a certain number of gems that Rails is dependent upon. If we look at this gem file, you can see what they are. So it's a list of the different gems, and it's just the way it's specified is the keyword gem, then what gem it actually is, and if you want to lock the gem to a particular version, you specify that version. So here we have an app that needs the Rails gem, the SQLite 3 gem to give us access to the database, SAS, which is the syntactically awesome style sheets, so that's a gem, Uglifier, which is what compresses the JavaScript assets before they're sent out to the end user. So it takes JavaScript and it turns all the variables into single character variables, removes all spaces. It sort of compresses JavaScript without actually changing the functionality of it. This one here, Coffee Rails, allows you to write Coffeescript instead of JavaScript, which is a different dialect of JavaScript that gets compiled to plain old JavaScript, etc. There's a bunch more. And anytime you add a new gem to your Rails project, you want to make use of a new gem, what you do is you add it in this gem file. You go to a new line in the gem file, you say gem, the name of the gem, and you could leave it like that, or you could also specify a version, and you would go back to the command prompt and you would run bundle install, and it would install that new gem for you. So I can close this up without saving. Okay, so at this point I can cd to my to-do list folder, and I can run Rails server. There's also sort of shortened forms of all of the Rails subcommands. So Rails S does the same thing as Rails server, just like Rails G does the same thing as Rails generate, or Rails C, which does the same thing as Rails console. And we'll look at the console a little bit later. So this will run, and this will bring up a Ruby-based HTTP server. So when we test our Rails applications, we're not using Apache, we're using something called WebRook, which is an HTTP server written in Ruby, and it launches itself on port 3000. So it's listening for HTTP requests on TCP/IP port 3000 on your local host. And so at this point, I should be able to open up my web browser and go to localhost, and it should then load up this welcome to Rails. This is all Rails applications sort of have this welcome screen mainly just to test if everything worked well in the setup process, right? So sort of step one after you've set up a Rails application is just to load up the server, go to localhost, and see if you get this page. If you don't, something has sort of gone horribly wrong. And you can also click on this about your application's environment, and it gives you some details, things like what Ruby version you're using, what Ruby Gems version you're using, what version of Rails you're using, etc. Okay, but my Rails app isn't really anything at all right now. It's just this intro screen and nothing much else. And so what I'd like to do is I'd like to make a simple to-do list application where I have a table of things I need to do, and they're each going to have a description, and that's it. So I'm going to have a table that's going to have, let's see, 1, 2, 3, 4 columns. One will be an ID, one will be the description of the to-do item, and one will be the created at timestamp, and one will be the updated at timestamp. And so initially I'm going to create this with scaffolding. And so from the project folder, I have to make sure I'm inside of the to-do list folder. I can say Rails generate, or just G, scaffold. And here's where I describe to Rails what a to-do list actually looks like. And so I'll just call it, let's say these are tasks that I need to complete. So I'll say scaffold a task. And what is a task going to have? Well, it's only going to have a description. And I'm going to have that description be text. And just to keep things as simple as possible, that's all a task is going to comprise of. In a more full-featured to-do list application, I might also have, say, a Boolean flag for determining whether the task was complete or not. But I'm just going to keep things as simple as possible. A task is just simply going to be a description. And then I run this generator. And what this is going to do for me is it's going to scaffold out my model, my views, and my controller for my application. It'll also generate for me a migration file, which is a Ruby description of what the database should look like, and it'll describe what the tasks database table needs to look like. So all these files were now created for me. And you can see here's the migration one that was created. And we could take a quick peek at that before we actually run that migration. So I could go to the db migrate folder. And you can see here we have a migration task, which is defining the fact that we want to create a table called tasks, and that table is going to have a text column called description. It'll also have timestamps, and what's not mentioned here is that it'll have a primary key which auto increments. And so to actually get access to that table, I can, from the command prompt again, run rake db migrate. So there's two commands that we tend to run from the command prompt. One is the Rails command, and one is the rake command. And so rake is a task runner. It knows about all sort of Railsy things that you need to do, and one of them is running your migrations. And so we ask it to do that. We say, Rake, this is a task that has to do with the database. It's specifically a migration task. So rake db migrate. Running that will cause Rails to create the tasks table in the SQLite file that's in our DB folder. So by default, Rails is set up to use SQLite 3 as its database. We don't need to configure it to do so. We just run it, and it does what it needs to do. You can see that in the DB folder, we have this development.sqlite 3 file, and it just changed in size. It went from 0 kilobytes to 5 kilobytes, and back at this command prompt window, we see that my migration has run. Sometimes your migrations will not run. There will be an error, and often the error is simply shown by Rake returning no output whatsoever. So if you're expecting a migration to run and you run it and nothing comes out, that's a bad sign. If you run it and you get some description of what was done, that's a good sign. So I now have my database table in place, and I should now be able to go to my tasks path. And this is the scaffolding that Rails has built for me. It's built for me the model, which allows me to interact with that database table tasks. It's built a controller for me, which the router can call upon when it receives URL requests. And it's created a bunch of views which generate the HTML for this page and other pages. So if I go to click new here, I can put in a description. My first to-do item is finish my Rails lecture. Create task. And now you can see I'm at a different URL. I'm at /task/1, and that shows the task that I just created. It also shows a message that says task was successfully created, and that's just temporary. If I was to reload this URL, that goes away and it simply just displays the description of that particular task. Clicking on edit, I could then edit the task. So I could put an exclamation mark in there and update it. Clicking on back, I could go to this sort of index view that would show all tasks. I could then create another one. Take the bus home. And you'll notice now that for the take the bus home task, the URL is tasks/2, whereas for the other one, it was tasks/1. So each one of our tasks has a unique URL associated with it that we can get to by changing the numeric value in the URL. And again, back at the index page, I sort of see all of the tasks that exist. The show links take me to those individual pages that actually show just that one task. The edit links allow me to edit those tasks. And then I'm also given destroy links. I can say this task will not last. And so if I create this task, go back to the index, I can also destroy it. So that was all done auto-magically for us. Right? Rails built all of that code for us. Let's take a peek at that code to see what it's actually written for us, and you'll see some of it will be familiar to you. If you've been working through the Getting Started to Rails guide, a lot of the code that you'll see in these files is the code that you were asked to write in the Getting Started with Rails guide. So let's start with this page right here. This is the index page. And the other thing I want to do is from the command prompt, I want to run another rake task, which is called Rake Routes. And this has to do with my routing file. It specifically has to do with how all of the URLs are going to be mapped to my individual controller actions. It's going to generate a lot of output, so I'm going to redirect it to a text file that I can then open up in my text editor. Otherwise, it generates so much, and it sort of goes beyond 80 characters, so it's hard to read because it wraps around. So I'm going to do Rake Routes, and then I'm going to push it to a routes.txt file. So I'll just get a routes.txt in that folder, which contains the output of that command. And then I'll open it up in Komodo, and it'll be easier to read there. While that's executing, I can also open up some of the other files that we're going to want to look at. So I can open up the task model. It looks really small. It's simply a class called task, named as such because it needs to be mapped to the tasks database table. And so the model is always the name of the database table capitalized and singularized. So a tasks table will have a task class, and it inherits from active record base. And I can do things like add validations here. So I could say validates that the description has a presence of true. Some other files that I may want to take a look at: in the controllers folder, there is the tasks controller. And we're going to look, to begin with, at this index task. And so then I'm also going to go to my views folder. You can see there's a subfolder for tasks. These are all the views associated with the tasks controller. So I have a tasks subfolder. You can open that up and you'll see a number of files in there. The one I'm concerned about is the index file. And what you'll notice is that other than this file that starts with an underscore, each one of these files will have a matching method in the controller, or at least most of them will. Index in here, this index method, has an index.html.erb. This show method has a show.html.erb. This edit method has a edit.html.erb. So I'll open up the index. This is the HTML that is being used to generate this page right here. So if we viewed source, if I hit Control U, I view source, the body of this document, so that's like this stuff right here, you can see there's an H1, there's a table, there's a T head and a T body in it. If I go back to Komodo, you can see the same thing. An H1, a table with a T head and a body in it. This is ERB code. This is HTML with embedded Ruby. That's why it has an HTML.erb extension. It has a double file extension. So what's going to happen to it before it's used is first the ERB code within it will be run, and then we'll be left with HTML only, which then gets injected inside of our layout. Because if we looked at the source of what was actually sent to the end user, it was more than just what was in the view. It was the top of the HTML document, including a number of links to CSS documents and JavaScript documents. And it was also sort of the body and the HTML tag, including the closing of the body and HTML tag. The rest of that code is inside of the app views layouts folder in this application.html.erb file. This is where the views get yielded in to the layout. So I could put a little comment here. Each view required by a controller is inserted into the layout where it says yield below. So I just put in a little HTML comment there. And if I was actually to go and reload my source, that comment's in there as well, right? Because I added that to the layout, so it ends up in the output that's being displayed to the end user. But if it's a comment, so it won't actually be in the rendered output. So let's sort of stitch all these pieces together. I can open up that routing file that I generated. That was this routes.txt. Comes out looking a bit like a table. It has a column for something called a prefix, a verb, a URI pattern, and then a set of controllers and actions. And so this is how URLs get mapped to Ruby code. When a URL comes into the system, the router uses this information to figure out which controller method to call. And so when I load up /tasks, when I either click on a link or put a link into, or a URL into the location bar and press enter, that's an HTTP GET request. I'm fetching some data. And so here I'm fetching /tasks. If we look at the routing file, you can see that a GET request, the verb GET, to /tasks is going to load up the index action of the tasks controller. So the way to read this is the controller comes first, followed by a hash mark, and then the name of the action. There's also this part here, which the parentheses means the next part is optional. And what's optionally provided there is a format. And so you can build Rails applications that, when you provide no format, generate HTML, and you can provide things like extra formats to them. It's not going to work off the hop, but you could provide, say, .xml or .json, and you could have, oh, the .json one works off the hop now. It used to be the other way around. The XML one used to work by default. And now it provides a different output for the same information. So your views end up being representations of specific data. So I could do that also for any one of these particular things. Here's like the HTML representation of some particular data. And if I do .json, there is the JavaScript object notation version of that same data. So I have what I basically get for free with Rails is an API, because now other programs can access my web page by putting .json on the end of any of my URL and get a machine readable format of that page, which is super, super powerful, right? We're not only writing web pages, we're writing web pages and APIs at the same time without any extra work being involved. It's a pretty nifty feature. Okay, and so you can see, if we again look at that routing file, if we look at, for example, the page that shows us an individual task, /task/ this particular number, that is right here. A GET request to /task/ID will load up the show action of the task controller. And again, there's an optional format on it. So let's look at both of those piecewise. We'll look at what happens when /task is fetched by way of a GET request and the index action is called. And then we'll also look at what happens when /task/some ID gets called and the show action is executed. We'll start with the index. So, okay, it's telling me the index action of the task controller. So I have a task controller, I can go to it. Here's the index action. And all this is plain old active record, which is why I present active record to you first before introducing Rails, because now you don't have to learn both Rails and active record at the same time. You already understand how active record works. What's happening here is we're going to our task model and asking for all tasks. And we're going to get a collection of tasks back. And I need to plug my computer in, which I will do. And then I'm saving it to a @tasks instance variable. This is one place where Rails sort of breaks object orientation purposefully. The whole tenet of object orientation, or one of the main tenets of object orientation, is the idea of encapsulation. The fact that our instance variables are private to our object. Rails breaks this in that it's now going to share this tasks instance variable with the associated view. So what happens after this method gets called is the next step is going to be the associated view is now loaded, and the associated view is in the app views tasks folder, and it's called index.html.erb. It's just the name of the action, index followed by .html.erb, and this view will have access, or will be able to access the tasks variable, which contains all the tasks from our database. So it's almost like the controller is a staging ground for data. I've mapped the URL, I've gone to /task, And now I've gone to the model and I've fetched all those tasks and I've put them into a particular variable. Now the view's loaded. What does the view do? Here's where embedded Ruby comes in handy. Inside of this block and this associated end block, I'm doing an each loop. I'm going to that tasks variable, .each, and calling each task in turn task. The really neat thing about ERB is that you can mix and match it with HTML. So I start my ERB block here, and I end it here, and suddenly I'm writing HTML again. So if I got rid of all of this middle stuff just for demonstrative purposes here, let's just delete those 4 lines. Oh, not all 4 of them. Oh, I think I deleted 44 lines there. There. And I just put the word woot. I should see the word woot now as many times as I have tasks in my database. So if I go back to my index, I have 2 tasks in my database, so I see woot twice. If I was to add another task and go back to the index, I say woot woot woot. And so this loop here is looping over HTML and generating it. So if I was actually to view source, not only would there be 3 woots in my source, but there would be 3 TR elements that have been embedded in the source. And so if I go back there, I view source, you can see there are those 3 TRs, each one with the word woot in it. But I don't want to say woot. What I want to say is I want to actually display the contents of each task, and that's what was there before I deleted it. TDs are our columns in the table that's being generated here. And here's an embedded Ruby that it doesn't just start with less than %, but it has an equal sign. And what the equal sign says is echo. I want to take some variable data and embed it in this document. So inside of this TD, the current task's description is going to be displayed. Inside of this TD, we're going to run what's called a helper to actually build an ahref link with a text of show that links to this particular task. And so we don't even manually build links in Rails. Like to build a link, we would never do a href show and then, oh, sorry, show wouldn't go there anyways. If I was building a link, show would go here. Because what am I going to link to? How would I know where to link to? And so by knowing the format of the show, if I reload this, I'll probably have to save this. I should not put typos description. I know that my show goes to each numeric value in turn. So I could manually build up the href. I could say this should go to /tasks/some number where the number is the ID of the task. So I could manually use another embedded echo to do task.id to build up those things for us, right? I could go back over here, and now these are my manually built shows versus the auto-generated shows. But why would I do all that when I can auto-generate it without having to do that extra code? So that's what this link to show task does, is it builds an ahref that will link automatically to our individual tasks for us by building a link of this format, /task/numeric ID. The edit does the same thing. We're building a link to edit, and here we're asking for the edit task path, and we're passing in the task variable. This comes down to the routing file again. The routing is 2 ways. So not only does the routing allow us to go from a URL to a particular controller action, we can also use routing to automatically build URLs for us. So if I want to automatically build the correct edit link for a particular task in my system, I look in my routing file and I see that I have a prefix called edit task. And so if I want the edit task path, all I need to do in my view is run the edit task path command, passing in the current task. And it's going to generate for me the correct edit task path, which has a format of /task, the numeric ID of the task in question, /edit. So if I looked at all of these edit links here, we would see that each one of them was structured in that way. The first one is /task/1/edit, /task/2/edit, /task/4/edit. So this little helper here allows us to link to things without having to know exactly how to build that URL ourselves. The router will build it for us. And then finally, we have this destroy link. We're saying we want to destroy this particular task. And it has a bit of extra information on it. Because again, if we looked at our routing file, if we look in this verb column, there are a number of things that are GET requests. When we went to the index page, it was a GET request. When we went to the show page, which was here, it was a GET request. But HTTP is comprised of more than just GET verbs. There are other verbs. In our server-side course, we make use of two of them. We make use of the GET and the POST. But there's actually more verbs than that in HTTP, and Rails makes use of most of them. To destroy a link, it uses the delete verb. To update a link, it uses both the patch or the put. And this is just a transitory thing. They're sort of switching from put to patch. So right now it accepts both. So there's other verbs, other HTTP verbs. And so to build a link that actually deletes something, when I click on this destroy link, I actually want to delete something. When it's built, I specify that a method of delete should be used. Because by default, links always use a GET. The way the web works is if you click on the link, it's a GET request. This is a way of circumventing that. And this data thing that's happening right here, this is what allows us to have some JavaScript that's actually run. When I go and click on destroy, it asks me, are you sure? And that's because this is there. So I could say, you know, instead of are you sure, do you really want to delete this? I go back over here, reload my page, and now when I go to destroy, it says, do you really want to delete this? Which is just like a JavaScript confirm dialog. And so that's the index, right? That's the flow of the index. We went to we did a GET request to /tasks. That mapped us to the task index, which took us to this controller action. It executed. It went to the model, fetched all the tasks, saved them to a tasks variable, which was then made accessible to this index.html.erb. This was then handed off to the embedded Ruby interpreter. All the embedded Ruby was executed. It was then injected into this application layout and then sent to the end user. How does that sit with everybody? It's a lot to take in, and that's why I sort of draw that diagram, right? Because that diagram shows that whole flow. The request comes in, you go to the routing hands off to the controller most often goes to a model to fetch some data. The data it fetches, as long as it's been saved in an instance variable, goes to the view gets injected in the layout gets sent back to the web server, and the web server sends it back to the end user. Yes, and so I try to write my PHP in a Railsy kind of way, but it ends up all being typically in one file rather than spread out across a bunch of different files. But yes, and you can write PHP in this manner, and there's a bunch of PHP frameworks that sort of replicate this kind of Rails style routing model view controller pattern. Some of the methods here have nothing in them. Some of them have a bunch of stuff in them. And then there's some private methods down below. One of the private methods is called setTask. And all it does is it does a request to the model to find a particular task. And here it's saying params at position ID. Params is a special hash where all HTTP parameters end up. And so HTTP parameters are either things that are posted to us by way of forms or things that are in our URL. If we look at the routing file, and we now focus on what happens when I go to show any one of these. So here was my very first task. If I click it, the URL contains a 1. And we see the particular task that's associated with the primary key 1 in the database. If we go to the routing file and look at show, we see that if we just remove this optional part just for clarity's sake, we can see that when a URL comes in that's /task/some ID, it's going to show that ID. And ID here is written as a symbol. It's :ID. And so the ID, where it ends up, is inside of this params hash. That's why we're looking at params at position ID here. And so, although this is sort of hidden from us, what's actually happening in the show is that this is being executed. So when we go to show/1 or show/2, the ID that was identified by the router in the ID placement after the word tasks ends up in the params hash, and it's used as a parameter for find. And all that find does is it finds things by ID, and then it saves it into task. And then what happens, just like before, the associated view is now loaded. This time the associated view is the app views tasks show.html.erb, and this view will be able to access the task variable, which contains the task with a primary key of, and then whatever was in the params hash at position ID, and that actually came to us by way of the URL. Now, why wasn't this in there? The reason that wasn't in there is because of this line right up here. This line right here says before action set task, and then it defines that set task should be executed for only the show, edit, update, and destroy actions within here. So this isn't actually needed because that's sort of duplicate code. All of these actions, what they all have in common is that all of their routes involve an ID. When we're showing a particular task, we need to know which task to show. When we're editing a particular task, we need to know which task to show in the edit form. When we're updating a particular task, we need to know which task to update. And when we're destroying a particular task, we need to know which task to destroy. So in all cases, we need to, if we look at the routing file, for show, edit, update, and destroy, they all have an ID in them. There's the edit one, has an ID in it, show, update, and destroy. So all of those tasks are called all of those routes are called member routes because they involve a particular task in our database and they need to refer to it by ID. And after executing any one of those URLs by way of their associated verbs, the ID will be in the params hash. So instead of having this replicated inside of each one of those actions, we could do that, right? I could have that inside of edit, I could have it inside of show, I could have it at the top of update, and I could have it inside of destroy. But instead of doing that, we just have this one command up here that says, before the actions show, edit, update, and destroy, run set task. where set task is defined down below as a private callback called set task, which does just that. It looks to the params hash, looks for an ID, and tries to find a task by ID. So it's just a way of removing some duplication. That said, we've executed this show. We've got ourselves access to the task at hand, the one that was mentioned by way of the URL that's ended up in this params hash. And so if we go load up that show view, which is right here, you'll see that it makes use of this task variable. In this case, it's inside of a paragraph tag, it's writing out the word description, and then it's echoing using ERB that task's description. It's also embedding two links into the page, one of them being an edit link where it's asking for the edit task path of this particular task, and a back button, which is just going to tasks path. And again, to find out where that actually goes, we'll go to routes and we'll see that the prefix tasks goes to our index. So when you add underscore path to any of these prefixes, you can build a link to that place or to that particular route. So by saying link to back tasks path, that actually links to our index action by way of the router. And so that's just index and show. There are a number of other actions here. And I'm not going to review each one of them in turn for you. This is why you have to go and do the Intro Rails guide, because it gets you to actually write out by hand each one of these actions. What's present in the auto-generated controller is even more than you need to know. There's a bunch of work being done here to handle both HTML and JSON representations of creating a task or updating it, which is more than you would actually need to do. So that's something that that you can sort of gloss over when looking at this, and instead of worrying about supporting JSON here, we could just bring this down to that, and it will look a little bit more like what the guide looks like. In fact, I could even take it a little bit more. Now I don't need to respond to a format. That probably looks a little bit more like what the guide has you write. What you do need to know is that a few of these tasks come in pairs. New is paired with create. Edit is paired with update. And so you have particular tasks that you're working on, and this is a task as in a programmer task, not one of my tasks here, but you have particular things that you're working on CRUD-wise, create, read, update, and destroy, that sort of require two steps. So for example, creating a new task, you have both the action of clicking on new task and going to a place to input that new task, which is /task/new. And then you have the actual action of creating the task in the database. So there's two separate steps to creating a task. One, the user is provided with a form to use to create the task, and two, the task actually has to be created in the database when I click on this create task. So that's why, if you look at the routing file, there are two separate routes. There's a route that is /task/new, which takes us to that new page. And if we were to look at the view folder, we would see that there was a file associated with that. And when the form in this particular view gets submitted, if we go and view source, we can see that what's happening here is that we're going to be posting this form to /tasks, if we go and look at the routing file again, you can see that the URL /tasks serves two purposes. Again, if I get rid of this format here just to clean up the look of what's happening here, I've hit insert. You can see that there's the /tasks URL is used in two different contexts depending on the verb it was used in. So if you do a GET request to /tasks, it's going to load up the index action. But if you post some data to /tasks, it's going to call the create action. So it's going to do two separate things. Oh, yeah, sure.
Sorry about interrupting.
It's okay.
Thank you.
So this is something you don't normally see in other, like in something like PHP, although you can with certain PHP frameworks, but you have a URL that does two separate things depending on the verb that's used with it. When you post to this URL, the create action is called. When you get to it, the index action is called. And then these are the two actions that are used in pairs. The new action displays the form that is needed. The create action actually takes that data in and creates it. So if we looked at the controller associated with those things, the new action, all it does is create a new task, an empty one, a blank one. Whereas the create action is responsible for not only creating a new task with the task parameters that are coming to us by way of the form, but also saving it. And depending on whether it saves or not, we're either going to redirect to that task and say that the task was successfully created, or else we're going to render out the new view, and that's going to display the error messages that are associated with things. So if I go back here and I say create task and I try to create an empty one, that's when I get this message. If I create a successful one, I end up at the actual task path of the newly created task /task/5. This thing here is the last thing I'm going to talk about today. The task params, it's actually a method call to this method right here, which goes to that params hash where all data is gathered, and it asks for data that has to do with a particular task, and the data it specifically wants is the description, and because that's the only bit of data that's associated with the task. If there was more data that we were setting in our form, if our task had more columns, we would list them out here. So if there was also like some Boolean called completed, we would have to have that listed here as well. So that's sort of the high-level overview of what scaffolding does. There's a lot to it. You can see this is why learning Rails is a complicated thing, right? Because you're not just learning a programming language. You're learning a whole sort of methodology for creating websites using a programming language. So you're using the Ruby language, but you're also using the active record gem to access your database. You're also making use of routing that takes particular URLs and associated verbs and maps them to particular controller actions. You're then sort of dealing with a controller that, by way of active record, gathers up data, saving it into instance variables. And then there's a mapping between the names of the actions that are being called and particular views that exist in a views folder. Inside of those views, there's more Ruby, but this time it's embedded inside of special ERB tags, and it's executed. Sometimes that involves echoing into the document itself. And then once that's all completed, that gets injected into the layout, which then gets sent back to the end user. So there's a lot happening all at once. The working through that, getting started with Rails guide is super important. You may want to work through it a few times because it describes to you step by step every step of this process. The other thing we'll be doing in class is we'll be just building a bunch of Rails applications. So the only way to really learn Rails is just to use it a lot. So we'll start off by building a few applications just using scaffolding alone and not worrying so much about the code that's being generated. And then we'll get more comfortable writing applications where we don't have to rely on the scaffolding. And so I'm going to stop my screencast now because I'm done speaking.